Greetings to all. In the last video, we had discussed about the subgraph. In this video, I am going to discuss about the induced subgraph and underlying sample subgraph. Subgraph which has all the edges corresponding to the vertex sets, it's called induced subgraph. What it means? A subgraph, if we consider an original graph, a subgraph of this original graph called induced subgraph. If we have the original graph like G and its subgraph maybe G1. This G1 is an induced subgraph. If we have VG1 a subset of VG, and moreover every X and set of EG, it should be, we can find this H and set of V1. Let me show an example. Here we can consider a graph, and then I am finding the subgraph of this graph, and then we will say to which subgraph is a induced subgraph. For example, I have this graph by this vertex. Let me label this graph by A, B, C, D, and E. This graph is, I am considering the edge of this graph like this. Okay, we can call this graph G, and now I am going to consider two subgraph of this graph like G1 and G2. We can call G1 and G2. Okay, it is G1 graph, and we can label this same. We have A vertex here, B vertex is here, D vertex is here, and also C vertex is here. We don't have C vertex, just we have E vertex. That is the graph G1. And let me have one more H here, and one more subgraph of this graph I am considering like this. It may we call G2. Now in here, according to the definition, the set vertex of the graph G1 is a subset of vertex of graph G. So every vertex of this graph is consists in the set vertex of G. So we can write V G1 or V1. VG1 is a subset of VG, Okay. Now, corresponding the vertex set of this graph, if those edges to create it, and those vertex to create it an edge in this graph, if we also can find between those edges and the original graph also an edge, created an edge, then we can say this is an induced subgraph. and otherwise it is just a subgraph. Okay, and here the vertex A and B, here they created an edge, this edge, and the original graph also we have between A and B, here we have an edge, and here B and D, these vertices created an edge, and the original graph also we have same. Between A and E also created an edge. A and E created an edge. E and D created an edge, and the original graph also we have same. B and E, they created an edge, and the original graph also we have same. So we can say it is an Induced subgraph. Let's go to, and I want to apply the definition on graph G2. On graph G2, let me label the vertex of this graph also A, B, D and E. And here we can see between A and B, B and D, D and E, E and A, here is edges available, and original graph also we have same, but between B and E and original graph, these two vertices, they created an edge, but and this subgraph G2, here is not an edge according to the definition. So we can say it is a subgraph, but it is not Induced subgraph. G1 is an Induced subgraph of G, but G2 is not an Induced subgraph. So from here we can say every Induced subgraph is a subgraph, but every subgraph is not an Induced subgraph. Let me go to underlying sample subgraph. Let G be a general graph, the subgraph obtained by deleting the loops and parallel edges, just keeping one length. It's called underlying sample subgraph. Underlying sample subgraph. Okay. What is a general graph? As we had discussed in the older videos, a general graph is a graph having loops in parallel. We calling a general graph. Let me show in the graph here. We can label this graph also by A, B, C, D and E, and let me have some parallel also, and loops also we can consider, and also we can consider some other parallel or some other loops also. It is a general graph because it has parallel. As we said, parallel is if two or more edges has same end vertex or same terminal vertex, then these edges we are calling parallel edges. And loops, if an edge has same end vertex, one end vertex, or we can say if an edge coincide in the same vertex, then we are calling that edge loops. In this graph, as it is clear, these edge and this one, these are parallel because they have same vertex. This C and D, same and vertex of these edges are C and D. And here also this edge and this one, these are parallel. And the loop, this is a loop. This edge is a loop. This is a loop. We can call this edge loop. And this is parallel. Parallel. It is also parallel. This edge is also we are calling parallel. Okay. So has we are this graph have parallel and loops, so this graph is a general graph. And now I am going to deleting the parallel and loops of this graph. The obtained subgraph is underlying sample subgraph. Okay, let me do this. I deleted, let me label the vertex of this graph. Also here we have vertex D. So as it is clear, this graph it don't have loops and parallel. So by deleting the loops and parallel, a general graph, we are getting a subgraph. The subgraph we are calling underlying sample subgraph. Thanks for watching this video.